Hello friends, welcome to the YouTube channel of Chamili Devi Institute of Pharmacy Indore. I, Ashish Kumar Parasar, Associate Professor of CDIP, today going to discuss Preformulation Part-II, which is the next part of Preformulation we have discussed in previous video. As per the definition of preformulation, preformulation is a phase of a research and development process where the preformulation scientist characterizes the physical, chemical, and mechanical properties of a new drug substance in order to develop stable, safe, and effective dosage form. Next property is particle size, shape, and surface area. Various chemical and physical properties of drug are affected by particle size distribution and shape. Size and shape also affect the flow property, mixing efficiency, dissolution, and other biopharmaceutical behavior of the drug. Fine material are relatively more open to attack from atmospheric oxygen, humidity than of coarse material. Particles can be classified as very coarse, that is sieve number 8, coarse, that is has 20, moderately coarse has 40, fine 60, and very fine, that is 80. Now the methods of determination of particle size. There are many methods to determine the particle size. First one is sieving method, which is this method is the simplest and inexpensive method. However, only 50 to 150 micrometer size can be determined by using this method. If powder is not dry, the apparatus can get clogged, so this method cannot be used. The second method is microscopy, in which from 0.2 micron to 100 micron meter size can be determined. Particle size can be determined by the use of calibrated grid background. Most direct method, slow and tedious however. Next method is sedimentation method. In this method, a particle size range from 1 micron to 200 micrometer can be determined. In this method, Anderson pipette and Anderson apparatus is used to determine the particle size. Particle size is calculated by the Stokes law, that is, diameter of the particle is equal to under root 18 eta h upon rho s minus rho 0 into g t, where h stands for the distance of fall in time t. Eta 0 is the viscosity of the medium, rho s is the density of the particle, rho 0 is the density of the dispersion medium, and g is acceleration due to gravity. Some other methods include light energy diffraction, in which 0.5 to 500 micrometer particle size can be determined. Particle size is determined by the reduction in light reaching the sensor as the particle dispersed in a liquid or gas passes through the sensing zone. This method is quick and fast. Counter method is the example of this method. Next method is laser holography, in which 1.4 to 100 micrometer can be determined. A pulse laser is fired through an aerosolized particle spray and photographed in 3-dimensional with holographic camera, allowing the particle to be individually imaged and sized. Now the methods to determine surface area. Particle size and surface area are inversely related to each other. Smaller the drug particle, greater will be the surface area. Specific surface is defined as the surface area per unit weight SW or per unit volume SV of the material. Surface area is most commonly determined by the Brunner-Emmett-Taylor BET theory of adsorption. Most substances absorb a monomolecular layer of gas under certain conditions of partial pressure of gas, that is nitrogen, and temperature. The volume of nitrogen gas Vm in centimeter cube that is 1 gram of the powder, can absorb when the monolayer is complete, more accurately given by using the Beatty equation, however, which can be written as P upon V, P0 minus P is equal to 1 upon VMB plus B minus 1 upon VMB into P upon P0. Now particle shape. Particle shape will influence the surface area, flow of particles, packing and compaction property of the particles. Particle shape may be spherical smooth, spherical rough, spherical irregular, rounded, angular, elongated irregular, acicular, angular, dendritic, any of the shape. Next property which we determine is the crystallinity and polymorphism of the drug substance. Crystal habit and internal structure of drug can affect bulk and physicochemical properties of molecule. Crystal habit is description of outer appearance of crystal. Internal structure is molecular arrangement within the solid. Change with internal structure usually alter crystal habit. For example, conversion of sodium salt to its free acid form produce both change in internal structure and crystal habit. In this figure, we can see different structures of crystal like cubic, octahedron, orthorhombic, monoclinic, trigonal, hexagonal, tetragonal structures of crystal. Depending on internal structure, compounds is classified as crystalline and amorphous. Crystalline compounds are characterized by repetition, spacing of constituent atom or molecule in three-dimensional array. In amorphous form, atoms or molecules are randomly placed. Solubility and dissolution rate are greater for amorphous form than crystalline, as amorphous form has higher thermodynamic energy. For example, amorphous form of novobiosine is well absorbed, whereas crystalline form results in poor absorption. Many drug substances can exist in more than one crystalline form with different space lattice arrangements. Polymorphs, monotropic and enantiotropic. Monotropic, one polymorph is unstable at all temperature and pressure, e.g. glyceryl stearate. Enantiotropic, by varying temperature and pressure, one form is changed reversibly into another form, for example sulfur. The example of polymorphs, chloramphenicol, it exists in three polymorphic form A, B, C as a chloramphenicol palmitate in which B form is stable, then rest two form. So friends, thank you very much for watching this part of preformulation. We will discuss more properties in the next part of preformulation videos. Thank you for watching this video. Thank you.